In global education today, there are a number of challenges facing the world. With COVID, we've just gone through the biggest disruption to traditional schools in the history of schooling, quite literally, where huge amounts of students have been stuck at home learning online, or they've been actually unable to attend school of any kind because of some of the COVID in-person restrictions. But there is promise. Innovations like online schooling are helping to pave the way for a more sustainable, more stable schooling infrastructure going forward. But today I want to focus on something that isn't yet resolved, and something that is going to be very relevant to all of you listening in high school and around the world as you go forward with your education. And I think it's one of the biggest crises that exists in modern schooling, and that is the computer science crisis. At the moment, computer science is one of the world's most in-demand jobs. In Silicon Valley, data scientists, computer scientists, user experience researchers, product managers are some of the highest paid young people in the world. Companies worldwide are trying to innovate in a digital age, looking at historical data, trying to build websites, trying to build applications, and all of this requires computer science skill and know-how. However, in the world's schools, there is a massive deficiency in computer science knowledge. Now, why this exists is because for much of the last 20-30 years, computer science hasn't been as important in the economy as it is today. And what this means is that many teachers have been prioritizing developing the skills in areas like biology, chemistry, and physics. As a result, in the actual teaching universe of available teachers, there aren't actually that many computer science teachers. The supply simply doesn't exist. The other reason for this is that if you could choose to be a computer science teacher or actually go and practice computer science in the industry, you're often going to do the latter because you earn significantly more money. An entry grad at Facebook is often on $100,000 plus. Where teacher salaries are typically half that or less in many countries when you get started. So there's both a lack of available current teachers, but also a lack of motivation for people to join the teaching industry to teach computer science going forward. Now, I want to stress just how attractive computer science is as an industry. Every year, we send students from around the world to the world's leading universities and then track their progress to leading companies, etc. At this point, 7 years into my entrepreneurial journey at Crimson Education, we've sent students to Facebook, Google, Amazon, through Y Combinator to top hedge funds like Bridgewater, companies like Brex, etc. Now, those doing computer science, typically out of a high-achieving university, often are earning more than 100,000 USD plus as soon as they finish school. Now, of course, this varies, and for example, in London, you might be on something like 60,000, 50,000 pounds. And then in, say, New Zealand, you might be on more like 70,000 NZD. But the point is, computer science is one of the most high-paid areas coming out of school. And that's for two reasons. Number one, there's a shortage of computer scientists, as I've talked about. But secondly, the value you can add as a computer scientist is absolutely huge, because you can help to automate many of the tasks that a company does and also build quite innovative products. Now, the problem actually goes beyond just the lack of teachers for computer science. It actually also seeps into the existing computer science curriculum. Now, in my high school, which was one of the highest achieving high schools in New Zealand, we actually viewed computer science as a pretty lacking subject. It wasn't very rigorous. What this meant is that high achieving kids wouldn't get involved in computer science traditionally. It was seen as more of a relaxed subject at school. Now, the result of this is that typically computer science curriculums in, say, A-levels are not particularly challenging. And they get even worse when you look at national curriculums, like, for example, NCA. So the existing curriculums aren't particularly rigorous, and also they're often quite disconnected from what you need to know to actually succeed in the industry. Typically, they focus on not practical skills. You don't typically learn how to build an app or website with the existing computer science curriculums that are out there, and the mathematical rigor is also lacking. A lot of top computer scientists have to be quite good at statistics and math, but those factors are not often assessed as part of existing curriculum like A-levels, like the IB around the world in a deep way. In fact, much of computer science is more like IT, learning about how things like computers work, the hardware, etc., security, as opposed to core skills like systems engineering, data science, algorithm design, things like this. Now, what's very interesting is we have now thousands of students studying at the world's top universities. So over the weekend, before this TEDx talk, I ran a poll. And I posted in our alumni community and I asked them a very simple question. I want you to tell me which subjects you find most useful at university in your success. Now, traditionally Crimson kids are very academic, so they're doing subjects like biology, chemistry, physics. They might do a French or a Spanish, math and English. They of course love the humanities, but they have that strong STEM leaning, science, tech, engineering, math. What's quite funny is the top 3 subjects actually at university, number 1 was math, but number 2 was computer science, and actually 3rd place was economics. But this is remarkable because virtually none of these students around the world, and this is a global phenomenon, not just in the UK, but also in New Zealand, Australia, parts of Korea, etc., is that computer science is hardly taken by highly academic students. Yet when these kids get to top universities, it often becomes one of the most important subjects they learn. Now, computer science was voted top 2 by our alumni community. But what's more interesting is that many of the students have a strong math background. So, unlike, say, math, where they've actually been trained in math for many years and reasonably rigorously in things like further maths for A-levels, computer science is something they've often got to pick up, which means come freshman year, they've got to take an introductory computer science class and start learning from basically the ground up. Meanwhile, in some high-performing schools in certain parts of the world like Silicon Valley, you've got kids as young as 5, 6, 7 beginning to learn computer science. So by the time they're 18 years old, they're off a significantly more advanced level. And in fact, I knew kids from Harvard undergrad that had interned at companies like Facebook after high school because their computer science skills were so good. So what this means basically is the second most popular subject at university for the world's high-achieving students is systematically not taken and pretty weak in existing schools. So this is a massive issue. Kids are picking up computer science too late, and the teachers don't actually exist to teach the subject. So I forecast in the future that in today you take math, English, 3 sciences, but the student of the future will be taking much more like math, computer science, and economics actually as their core load. Subjects like Mandarin will become more popular than subjects like French and Spanish, but computer science above all else will rapidly grow in prominence as there are more and more ways to take this in school. Now, I want you to just think about in your day some of the experiences you have and how prolific the impact of computer science is. You may have caught an Uber recently, on the way to see a friend or something like this. The algorithm that matches you to a taxi and then connects you to a car within a matter of seconds and typically makes a car physically arrive in front of you within a matter of minutes is a great example of computer science in action. When you go onto a platform like Netflix and it seems like they read your brain in terms of recommending you different movies that you actually really would like to watch consistently, that's another example of an algorithm being used in computer science. When you think about all of the ways in which you can now, for example, buy things like clothes online at pretty attractive prices, much of the efficiency in the supply chain, how they get these clothes from their factory to you, come through amazing technology systems built by computer scientists. The list goes on and on and on. As a young person, if you want to go ahead and create big social change, often the great ways to dispel your social movement are through things like websites or apps. And having the skills to build those tools means that in high school, the projects you want to do don't just stop at an idea, don't just stop at sort of a Facebook page, but you can carry them all the way through to an executable piece of technology. The next thing I want to mention about computer science is artificial intelligence. AI, as it's called, is the use of big data to make decisions that get better and better over time as more data is fed into the algorithm. Artificial intelligence is an important branch of computer science and is currently one of the world's highest paid fields. One of our alumni went from New Zealand to now working at DeepMind at Google in London, and at the age of 23 was on more than $200,000 US in net compensation, coming out of the artificial intelligence background. Now, AI is currently a big source of investment for companies like Amazon, Google, Facebook, Snapchat, TikTok, ByteDance, etc., because artificial intelligence provides a whole host of opportunities to improve businesses dramatically. Here's a powerful example of this in action. Take a doctor who's trained for a good 10, 12, 14 years in their craft, assessing x-rays. They're a radiologist. Now, it turns out that these days you can use algorithms built by companies like Google that have scanned more than 6 million x-rays to actually assess an x-ray and diagnose things like bone breakages more accurately than an x-ray, than a trained doctor actually can. So you've got an algorithm which costs basically nothing to run, beating human doctors trained for 14 years at the main job they've trained for. These types of innovations are happening across the world. In Australia a couple of years ago, when I was in high school, you could go to Australia and be a truck driver for a mining company in some of the mines in Australia and earn more than $200,000 a year. But now, these trucks are driven remotely by autonomous driving units. Companies like Waymo, one of our alumni from Crimson Song Huang's working at Waymo soon, which is Google's autonomous driving unit, is using artificial intelligence to actually remove the need for the driver in a car, and as a result dramatically increase safety. So computer science is critically important, but the branch of computer science around artificial intelligence is perhaps even more significant. So what can we do about this big issue? The first thing is we need innovative schooling models that tap into non-traditional supplies of teachers to meet this demand. In the short term, it's very hard to retrain a generation of teachers to become computer scientists. We can have people from math and physics moving towards computer science, but in the short term, we need to use our top young minds from places like Stanford, Harvard, UC Berkeley, etc., and take these top young computer scientists and use them to teach online across the world. I left a call earlier today with a young 13-year-old boy who's doing online schooling, and on the other end of the call is an Oxford PhD in artificial intelligence, training them on computer science and artificial intelligence from their home. Does this student have lessons from an accredited teacher? No. But is the person teaching them an expert in computer science, artificial intelligence, and able to really bridge that gap effectively? Yes. So the modern school is going to have a network of traditional teachers that have rigorous qualifications in core subjects, but is complemented by people that have been rapidly upskilled in computer science, typically who are recent university graduates, who want to give back to young people and teach online. Now, we recently launched an online school, the Crimson Global Academy, and we're doing just this, where students learning computer science can actually take computer science certificates, in which they learn coursework in things like artificial intelligence, Python, Java, C++, and they're actually taking a combination of accredited courses from Harvard, from Stanford, and doing a capstone project that builds these experiences. So overall, my message is clear. I see one of the biggest problems in global education in the developed world, being the computer science crisis. We've got a lack of teachers, it's an important industry, it stands to transform the world as we know it, and we need young people upskilled in this. It's the second most useful subject for our Crimson alumni, yet it's systematically neglected in schools. So I urge you to hop on computer science and be a part of the change to make sure tomorrow's generation of young people learn computer science and are equipped for the future. Thank you very much, and let's solve this computer science crisis together.